Welcome to the special edition of the Uptime Wind Energy Podcast. I'm your host, Alan Hall, and I am in Roskilde, Denmark, with the folks from DTU and R&D Test Systems because we have a brand new rain erosion facility. And I've just been attending the 5th Symposium on Leading Edge Erosion this week, and there's been a tremendous amount of new technical knowledge and test results and computational efforts going on across the world. And it's time to talk about the real rubber hit the road part, which is the rain erosion testing. And I have here today Nikolai Johansson with DTU, the Riso campus, which is the wind energy
and energy systems department.
Yes, and we just had a magnificent tour of the facility, and there's some amazing pieces here. I didn't realize what kind of technology DTU has. It's astounding. It's quite nice. It's better than anything I've seen in the United States. You should be proud of it. It's really nice. And this is one of those new facilities that has been built by Jesper Del Husker, who is with R&D Test Systems.
Correct.
So welcome to the podcast.
Thank you.
Thank you.
This is impressive. So we have talked to R&D Test Systems in the past about a lot of different things. One of them, rain erosion test facilities. This is a kind of a standard thing that R&D Test Systems does, because there's such a big demand for it.
Exactly.
And I haven't seen this up close, but seeing it up here now, this is amazing. This is a really nice setup, well thought out. And this setup is the most advanced one in the world at the moment.
Exactly.
So you want to describe what makes this the most advanced rain erosion test facility?
Yeah, first of all, the test chamber is larger than normal. One builds. It's we normally either deliver the system within 2 containers, 2 20-feet containers, high cube containers, or we can deliver it into a building, so we can integrate it in a customer building solution if they want to have a building instead of this modular. But then we have thought of a lot of these containers. It's not. That's nice to look at, this container, but still a building is very expensive for our customer to build themselves. So we kind of designed a middle way in this one, where we have this steel structure that we have welded in our workshop in Hinderup. And then we have mounted these sandwich panels with 80 millimeters insulation.
Yes, it's quite warm in here. It feels good.
Exactly.
It's because it's cold outside.
Yeah, exactly. So that should both cope for the temperature and for sound dampening. Because it's a very loud machine when it's beginning to turn around.
That's very smart design, because I think a lot of people wouldn't think about those design details of just the day-to-day operation. I've been to some of these facilities, and they are tremendously loud.
Yeah.
This one is going to make
really loud,
sense.
and one of the reasons we did it is because we have our own rain erosion tester at our facility, and it's very loud. so it's like, okay, we have an issue here, we have to solve it.
So Nikolai got the quiet one. He is the most quiet. Well, we're going to find out.
There's certain budget off for sound mitigation, because like one of the main concerns of course, like we are in an officially zoned industrial, so we are allowed to make noise, but of course we shouldn't both be noisy to our neighbors, but also more importantly, the wind tunnel just next door is designed to be an acoustic wind tunnel. So for sure, we will make sure that we're not disturbing whatever measurement is going on over there for measuring noise on aerodynamic profiles.
Exactly.
And again, the building was also one of the things we settled on relatively early in the process. So like way back when that's 2 years ago, when me and Jakob Ilsted, we went around literally scouting the old buildings at Riso to think, is there any of these old buildings we could fit in a machine? But then quite quickly, like modifying an old building to house this quickly turned out to be much more expensive than going something where we can control all the factors.
Exactly.
Yeah, it's very modular, and it's really easy to set up. How long have you been on site to actually start assembling this?
Well, we started, I think it was 1 week before Christmas. We were here 1 week to set up the test chamber. It came in like 4 walls and 2 floor section and 2 ceiling section. So we put that up. Also, this huge concrete block in here, 3 tons of concrete.
3 tons of concrete.
To ensure this stator and the rotor. So we put that up a windy and cold December day. I was in the office, but
I was out here.
thank you very much to
I was out here all day. I was
and our site installation crew. So they put that up. Then they left it. Came back after New Year. We had a blizzard. We had to cope for, so we got a little delayed. And then they began to build up all the steel structure, and outside we have a heat pump for temperature regulation inside the test chamber.
So it's a three-piece kit. So there's a little bit outside. There's actually two sub-buildings outside.
There's two sub-buildings. That's also one thing. Usually we only deliver one control facility. But of course, Nikolai wanted another one, or did you?
Well, that's okay, because I think you're going to need it with customers coming in and
so
the base.
The normal option does work, but you're sitting in a little bit of a shoebox, let's be honest.
You do.
So
For the control room, that's exactly what you need, though. And I think because it's DTU and you have a lot of people coming from the outside to it, you need a separate place where the engineers can huddle up. And
like typically, I think the large scale facility that's just next door, I think they managed 70 tours last year.
Wow.
So like the amount of public flow through is quite large. So it's worth considering that whenever you do anything here. And and then again, compare like the unique thing in the erosion tester here is that it's really the first one that's in a pure university setting of the R&D. Of course, there's the old machines from the cold era machines. They exist in some universities, but so far all the R&D testers have been in commercial settings to one extent. There's the one in Japan that's sort of semi-open, and then of course there's all Catapult's machine.
Right.
So
so we're talking in the beginning of February. So it's literally taking a little over 30 days to get you're going to be up and running in a couple
around
of days.
2 weeks, I think.
Wow. Okay.
That's a lot of when we have all the hardware installed and the wiring. Then we have a lot of running of the machine. We need to be sure that this is running as we expect. And that the test result is repeatability.
So
we can repeat the results, right? And to ensure that, we run 8 calibration tests, and these calibration tests we run for 10 hours each. So
10 hours continuous.
Yeah, continuous. To make sure that the calibration is correct.
Okay. And in the calibration, we'll talk about the calibration in a minute, because I think that's part of the details about this particular unit, which is unique in the way that it can, 1, control temperature, 2, the amount of water it can pump through it, 3, it has 2 different sets of needles that actually make droplets, and that's just what I visually see. I assume there's some other bells and whistles that are in this machine that make it unique.
Yeah, for sure. Again, we've had a lot of inputs in what the design we wanted in it, and one of the main things is the droplet generation system, as you say, because it goes back to studies we've done, and also R&D has been partnering projects there where we looked at various drop size and flow rates and amount of water, and one of the things we sort of pinpointed is, yes, you can accelerate the test by going faster, but it seems to provoke failure modes that we don't necessarily want. But there seemed to be leeway in adding more water into the tester. Or at least that's something we want to look at.
Agreed.
And that's where we beefed up a lot, both with, then we have one set of normal manifolds, that's 600 individual blunt needles that sit around and drop. And then we added the second extended manifolds, that's 20 needles per manifold for an additional 1,200 needles. So we go from 600 to 1,800 needles.
1,800 needles that are dropping water.
And Nikolai has to change them each week now. Not each week, but there's a lot of needles.
That would be a master student job.
Well, I think it leads to the point of the reason that this level of machine is needed today is because we still have trouble in service with leading edge erosion. It is one of the most universal problems that wind turbine owners and operators have today. Everywhere I've traveled in the United States, every wind turbine has some level. And we saw some presentations today from Brazil. It looked like next level erosion. It is a major problem, and the issue is not having enough test equipment the companies that make protective coatings to go test and to look at what the variables are. Because I think being at the symposium this week, that's one of the discussions is what variables are the variables that we need to focus on, and we don't have enough machines to go do that. And this machine is going to help eliminate some of those things that we've been talking about and get to some real data, I think.
Yeah, and at the level that there is, as we say, this will be the machine number 15. So there's a lot of these now in the wild, but as I say, they're within companies that they run more or less 24/7. Most of the machines I know, but they qualify. But for a university setting, that becomes limiting in what. If they already run it, everyone runs at the standard conditions, then we never really get outside the box and figure out the core driving things. Yeah.
It's the research part of this, which is the bonus you guys have, is that you can expand that envelope, whereas a lot of the testing, Nikolai, you're 100% right. If you go from R&D test system to R&D test system units, they're very consistent. That's why everybody loves those systems, because they do this focused thing. But as we were learning this week, it's a big world out there, and the raindrops aren't all the same. Yeah. And South America is different than North America, and Europe's a little bit different. So everybody needs to have their own understanding of what's happening, and we need to have the brains at DTU going to figure this out. Where else are you going to do this?
Exactly.
Yeah, it's here. And so in terms of what this system does, I think we ought to take a step back here, because if you're new to leading edge erosion and you've never seen one of these machines before, it is, Nikolai, maybe you ought to describe what it is, what it does, how it works, and sort of the magic of this system.
Yeah, so I can bring it proper in. So this is an example of an uncoated specimen we would put that would go into the tester, and with all the needles going around and the blade, you can imagine there's a higher tip speed at the tip and a lower speed towards the middle. And as the test runs, the sample is inspected at certain intervals, and you will see if it's well behaving, an erosion front progressing from the tip going towards the root. But in many cases, that might not be. But again, we broke it at certain stage, and we observe. The main observation method is through the camera system that will soon be mounted over here.
That's the key, yeah.
And that's also things that we might expand on. But as it erodes, then we can track the erosion, and we can measure the amount of water or rain that impinged the blade that got to that failure mode. And with that data, we can then go use a climate model, a rain model for an actual turbine site, and get to an estimate of lifetime for the site. We know even though this aims to replicate as much as the real conditions as possible, there's still a significant jump from what happens in here to what happens outside.
And this is a 3-blade system, so you can put 3 samples on simultaneously. Yeah. Would you do 3 of the exact same coating at the same time, or do they vary that?
Typically, we would always go with 3 of the same. One thing is if it erodes evenly, then the rotor remains more balanced.
Sure.
And also, it's again duplication and replication of results, so you get sort of a minimum 3 replicants of each material tested. And that's one of the things that, from my point of view, the biggest difference in historical rain erosion testers, also whirling arm testers, is that often there are short sample or coupons, so you're only really testing one speed at one time. So imagine if you were building a plot with velocity and number of impacts to failure, you would have to do repeat experiments for each time.
Sure.
Whereas with the longer specimen and the way the rain field is configured here, we get proportionately more impacts towards the root, but actually for one sweep around, each part of the blade sees the same amount of droplet impacts. But that means that you get a slightly more even erosion over, so you get more out of your samples. One sample can sometimes cover like 30 meters a second range from the tip to the root, so then you are like halfway to a usable curve, so you cut down significant on the time, but there's a bit more analysis on the back end.
So a lot of the rain erosion facilities in the United States are older, right? And there are 2-blade systems. So this 3-blade makes a lot of sense in terms of samples and running the samples and trying to get the most data you can for the time, right? There is a time element to this because some of these samples run for hours before anything noticeable happens. So I don't know what the typical length is. What's a typical length you run it for a coating today? What does that look like now?
It's varied a lot. Like when I started looking at data sets for you, then it was only like half an hour.
Right, I
but we were
remember
running
things in minutes.
Yeah, we were running it at full speed, and then it dropped down, and like now the things that runs for 300 hours. We saw some of we also had some of our own liquid LEPs, and the Dual Edge project, there was one of them we sort of had to give up on because after everybody's tested it for like 400 hours, like this, we don't have budget to run it for anymore. But yeah, so they become longer and longer tests.
Well, and that's the point, right? Is that we're trying to build more durable coatings so that we have less issues out in the field. But that also lends itself to R&D test systems. If you're going to run 400 hours for one set of samples, and you're going to do that repeatedly, this thing has to run, because my guess is that the line of customers that are going to be in here it's going to be busy.
Exactly.
This machine can't be down.
No.
Yeah, and it looks like you've over-designed this thing in a sense. What's the motor size that's actually spinning this?
The motor size is, if it's running 50 hertz, it's 37 kilowatt.
Whoa.
So that's a huge motor.
That is a huge
we
motor.
have seen sometimes when we run it in, things are going fast, and we had sometimes forgetting to put in the samples, and then we can't understand why it can't run above 1200 RPMs.
Yeah.
And we said, come on, but it's actually just the drag of the wind.
Really?
Yeah, that's holding it back. As soon as we then go in and put in the samples, then we can spin up to the aerospace version with the same motor. We can spin up to 1,790 RPM.
What's that in
So that's-
kilometers per hour?
That's 800 kilometers an hour
Whoa.
at tip speed. Just
Okay.
above. So
That is
that's for the
fast.
aerospace industry.
And what is the tip speed of this particular unit?
That goes to
173 meters per second.
Yeah.
So that's about 350 miles an hour or so, roughly.
Yeah, so actually it's 540 kilometers
Miles an hour.
Yeah,
Okay,
something
that
like
sounds about right. Yeah,
all the conversions.
no, we know. Sorry, that's America. Yeah, we use strange units. But that speed though is sort of needed because of the tip speeds. But we're also finding that maybe we don't want to run as fast because that maybe causes some unnatural things.
Yeah, no, then that's been, I think, the trend we have. So when I've been with dealing with some of the Erosion test data since 2016,
Yeah.
and we sort of see more and more people want to go lower and lower in velocity, and we've also gone down to realistic speeds. But again, it's on a power curve with an exponent of -5 or 8 or something.
Right,
So
right.
going a little bit down in speed drastically, it goes up in time.
Sure, but there's reasons to do that,
Yes.
and you have to have a reliable system in order to be able to do that. And if I'm a coding developer, at some point I want to run it at regular tip speed, maybe plus 10%, maybe plus 20%, and see how long it goes and before I notice anything. I think it's a valuable thing for customers of those materials. So yeah, that makes a lot of sense. Now, the complexity and the ability to add on to this, we're talking about cameras. It has lights, right? So it has lights to take photographs. I assume that the lights are to take photographs as the blade
Exactly.
passes through.
When it passes through, you can set up the test for a certain amount of time. So you can put it up. I want to have it analyzed each 30 minutes.
Okay.
So it will run at the setting speed for 30 minutes with water dripping. The water will stop dripping, and then it will dry the blades.
Okay.
And it will spin down to around 6 RPM, and then it will take the images. The light will come on, and it will take images.
So it'll do the photographs without taking the leading edge off to actually.
Yeah, exactly.
Wow.
So that's one of the things that makes it fast. Of course, you don't get all the details, but you can get an idea of where are we, and the operator can sit from remote distance at a screen.
Yeah.
Look, okay, now the next picture has come in. Okay, not enough erosion yet. We run it for an hour more.
Keep going.
Yeah, keep going, and suddenly, now we're there. Then they can go out and make a better analyze and a further analyze it. Maybe take it out,
Sure.
scan it or something.
Wow. Yeah. Well, and if you want to learn about the material, it's just going or weigh it. I guess that's the other thing that's done.
exactly.
Material loss, which can be done at DTU, right? You
Yeah,
can weigh
of
it.
course we can do, but I would say that's the downside of the long specimen, because you get erosion over a longer range, and you do get material loss, and you can measure it, but you'll never know at which velocity the material loss happened.
True.
So that's the downside to going a long distributed impact compared to the short sample.
Let me ask you this general question here, because there's different kinds of rain erosion facilities. When it's dripping water, are the water droplets timed, or are they just randomly happening? Because I've seen both.
They happen when they want to.
Yeah.
Okay, that's what I prefer.
That depends on the surface tension of what water's coming in.
And can you vary the water a little bit that goes through the needles? Is there a little bit
We can change the size of the needle, and we can change the flow rate. So we can put the flow rate up and down and adjust the needles depending on which droplet size you want.
And the basic science to sort of controlling it is that it's a sort of a semi-stable hanging pendant drop. And a hanging pendant, the size of a drop there is defined by the outer circumference of the needle. So that's the balance between the surface contact forces that says how big the droplet can be. So if you put in a bigger needle, you have a longer circumference and you get a bigger droplet.
Bigger drops.
But of course, this is sort of that would be in perfect steady state. This is sort of not in a steady state, but it still defines the needle to a larger extent. But what we might also want to look into is another mode of operation that's where you, instead of having them drop, we let them spray. That makes the distribution wider. But it might actually, from when we talk with our metrologists, or that's another department and another section of the department, the metrologists, they say, these 2.4 millimeter droplets, that's way too large. Most of the droplets in nature that we see in rain are much smaller. So it's one of the directions we will look into.
Well, that's why the machine is here, so you can do those adjustments, and that's why you call R&D test systems to make this thing, because it is adaptable. And if there's a lot of needles that have to be replaced still. I only see a couple of them hanging down. So is that a routine piece that has to be replaced every once in a while? It seems like they're heavily used. They're constantly
Some customers are having like a service maintenance interval that they change needle 1, needle 2, needle 3 at each manifold, and then over a year they have changed it all. Maybe.
Oh, they change them over the cycle.
So they're not changing every needle each day, but or each time. You could also do just to look at them, verify. Okay, now it's not dripping as we like it, and we can change that needle, or we can change the other one.
Okay.
But what we have seen, the most important is like an old diesel car. You need to get it running all the time, because
you need to run.
Yeah, run.
Run.
Then you don't need to change that much. And that's why we have one of the things DTU has requested here is to get a water recycling system for this one.
That, yeah.
So we implemented this also to get the water recycled. So we are using as less water as possible.
Because this system can use a lot of water.
Yeah, so the maximum flow rate is 400 liters an hour of the system, and in a traditional machine that would all go to the drain.
Right.
Of course, while the machine is running, a significant part is going to go out the ventilation because a significant amount of the droplets turn to mist. But again, these considerations, both with the heat pump and water reclaiming, let's be honest, it's not financial. It's not a viable option if you just look at the money, but I still, as a university, we have to take these considerations in.
Sure.
Like, if you look at the cost of everything and what it influences the cost of running a test, it's insignificant, but we have a responsibility to choose an option that minimizes the impact.
That makes total sense. I think it's a responsible thing to do. And let's talk about it from a customer's perspective, right? So if I'm a coding developer, or I have some new great idea about leading edge protection, I guess I'm calling DTU. That's the first thing I'm doing. And then what are the steps? What are the next steps I need to do? How do I get these samples made, these leading edges? Is that something I have to talk to you about? Do I make them myself? Is it how does that go?
It's a process we're getting into. So our plan is to up our own capabilities to both have. Traditionally, you will buy your shells from the main manufacturer right now is Olsen Wings, but we're also having molds made to be able to make our own, because there are sometimes an operator is concerned about what is the effect of the layup on the end erosion.
Agreed.
We're also moving into the realm of biocomposites. So
Sure.
And we've done some preliminary work with a student in Bergen looking at flex composites for impact resistance, and they seem to be quite good. So there could be something there. Yeah.
More testing to do.
Yeah,
Okay.
but then again, that will be one of the things we will focus in on over the next year to get the capability of to make our own. For the majority of samples, we'll probably buy them externally, and then we'll figure out how to code them. Something we'll code here, but we also have a collaboration with Fraunhofer EFRAM to join forces on some of the coding work. So again, it's a big community. I think that's one of the slightly unique things about rain erosion, that it's more open and shareable than I think a lot of sort of industry-driven technical fields.
It is. Right now it is, because everybody's trying to find a solution. There's so many variables.
And also, like, it was not the universities that started off the work on erosion. It was the OEMs and two joint industry projects, the Cobra and Biceps project, was sort of, I think Biceps predated our entry into rain erosion, and Cobra sort of came afterwards. But like, it's been sort of interesting to see, like, from a university that you can get both Siemens, Vestas, and LM to sit in the same room and agree to share data. I think was a
sure. That's not their core business.
No.
Their core business is making wind turbines and making them run a long time, right? And this is a problem that needed researchers and R&D test systems to get in the mix here to get the test equipment where it needed to be, and to just do what we just did in the symposium, and get all the smart people together in a room, and let's figure this thing out. So if I'm a customer and I get this leading edge, and I put my new magic coating on that's going to solve all problems, I come over to Nikolai and I say, all right, Nikolai, what happens? We install them on the test rig, and I tell you, just go test it. Is there a standard that's used in the world today to go test?
So there also one reason for this machine is it's covered by like two industry recommended practices. They're not quite standards yet, but I know there's something on the way.
Yeah.
So DNVGL has the two recommended practices. One describes the tester, and one describes how to use the data from the tester to go to the field. And I say that's of course the jumping off point. We have sort of more that we've developed on over the years working with it. So we would probably recommend that we start also looking at some of the dynamical mechanical properties with DMA testers, which we also have been invested in before the erosion.
I just walked through that facility, the materials facility. It's fantastic. So that's why you're at a research institute like DTU, is that you can hop over to the materials lab, check out the material before it even gets onto the whirling arm here.
Yeah, and again, it's what we're tied into. Like, the condition that happens in rain erosion is so different from all the other kind of mechanical tests we have, because it happens in like a split second.
Yeah.
When you look at the times, the peak stress has happened 2 microseconds after the droplet touches the surface.
Yes.
And like, even if you have the slightest amount of deformation, anything that happens in 2 microseconds means that you have both high strain and high strain rates.
Yes.
And those two things are very, very difficult to test in any conventional means.
They are.
Our
Yes.
best approach now seems to be like dynamical mechanical analysis and some of the impact testing we've done. But that's sort of our jumping off point now. But a lot more is going on to get deeper into the materials.
So if I get my material on, we get to the materials test, and we get it onto the rain erosion rig, it's going to run for how long?
Until
it breaks?
until the machine says it's vibrating too much.
Yeah.
I know
That's a good indicator. Yeah.
No, and then there's different. I think the general recommended is if it started eroding too much into the laminate, you should stop. I've seen there are some operators that are a little bit more brave, and they continue until it's eroded all the way through. But that's with the risk of losing a blade, which is why there's a
steel
1 inch.
plate. Is it 1 inch steel? What is it?
It's 20 centimeters.
20 centimeters.
almost
So
one inch.
I tried to be.
Exactly.
Wow. Yeah.
So even though
Does this get used in some of the testing? Like parts come off and it hits
parts
the
come out,
sidewall?
it hits the wall, take off the initial power of it and forces, and then it bounced back, and sometimes it takes off some hoses, and then of course we have a package for that you can buy. So you just say, Nikolai, when you do that, we are ready to come to Roskilde with our service department to fix it.
The service contract.
You're going to need it. Well, if it's used the way it should be, you're going to need service on it, and that's a good thing because R&D Test Systems is right there to come over and help you.
It's to ensure that the safety is always up to date, and that the machine is running as we expect. So we will check the rotor each year and the bearings and all bolts and nuts if we go them all through that to ensure that they are tighten and
that it
pre-tented.
works. Yeah, that's what the test phase is going to do before you really go live. And it makes sense that R&D Test Systems, obviously everybody knows, right? That company makes incredible machines that are unheard of in the world.
So we use the same procedure in this quite, for us, for R&D testing, this is a small machine, but we use the same procedures to ensure the safety.
Sure.
So even though we make these large-scale test system for the industry, then we use the same procedure here.
Well, just looking at it, it's magnificent. And I know we run across a lot of operators in the United States that are thinking about different kinds of coatings. And one of the questions is, how long is it going to last? And do I need to go do some testing on my own? I don't necessarily trust the manufacturer of coating, and I get it. And that's a common theme today. But they don't know where to go. And especially in the United States, there's a lot of large operators, 10,000 turbines or more, right? They need to come someplace and do some testing, and they have engineers. They have bright people, but they just don't have the facilities to come to. You need to get on an airplane, get over here to Roskilde and run some testing, because I think that's the way that they're going to convince themselves that they have a solution for their particular situation, their particular rain, their particular temperature extremes, their particular tip velocities. This is where you would go to do that work. And this whole facility is magnificent, and I'm so lucky to be here at this moment to see it before it goes live. And Jesper, congratulations. This is a lot of hard work to come into this. This has been how many years of your life that you've been sort of around this?
I've only been for R&D for 2 years, but I know my what's called predecessor.
Yes.
Was there for also 5 years, I think.
Okay.
And Nikolai has been there for the most of the time, supporting us.
The unofficial R&D employee.
Exactly.
So Nikolai, did you get a set of keys when it comes? Did you get like a new car? Or you get something that comes with it?
There was a weird key hanging over one of the containers that I stole.
We'll change the lock.
It's gonna make you feel proud. Like this is another thing that DTU does extremely well, and it just adds to the abilities of this research facility, and it's amazing. Congratulations! You're the elected recipient of a brand new rain erosion facility.
Again, it's the team effort, and I took over the last part, but it's been like the entire department coming together and agreeing. Jakob sort of starting it up, and then through the entire management getting it up and push it, because like we did this investment on internal funds, which is also like it's a big ask to say okay, we'll take our own money. It's part of the department is quite good at making its own money at time, and often it goes straight back to main campus, but then that allows us from time to time to do these investments that you can do this and try to look for funding, but then the process goes from like our total process was maybe 2 years, but a lot of it was just where we were waiting. If you're going the funding way, then maybe you are spending 5-10 years trying to claw the last bit of money out to do it.
It's wonderful to make a decision. I think it's very, very smart decision. It's a long-term investment into the wind energy community, and I think it's really going to pay off. And if any operator, owner, OEM is interested in getting up to DTU to do some testing, how do they find you on the web?
So if you search for the Risø Leading Edge Erosion Facility, you should hit our homepage. Otherwise, the wind energy systems, you go in and look under our system. So I guess there'll also be a link or something.
We'll put a link in the podcast for sure.
And then get in contact with me or whoever. We'll set up the process. We are still learning how the real workflow is going to be, but we have a large part of the department's business is commercial testing. So it's not that commercial testing is anything new from us. I think there's about 400 commercial jobs going through the labs every year. So there's a workflow for it. It'll just be a little different for this than some of the other tests.
So we'll put the website in the show notes, and I think there's a LinkedIn page also that people can connect to, and we'll get all that information out so everybody can find you, because this is the place to go. And Jesper, congratulations on this facility. It is magnificent. Nikolai, you're the luckiest person in Denmark at the moment, so congratulations, and thanks for being on the podcast. This has been wonderful.